Hello there, this is Sunny Lisewetsana along with Hussein Kasu and Tahir Mukadam. We'll be sharing with you on the topic shear reinforcing alternative arrangements of links. In this presentation, we will show you how concrete fails under point loads and the means of which to reinforce it with steel. We hope by the time this presentation ends, you'll feel much enlightened. And near the end, we'll have a little special on the future of shear reinforcement. Do enjoy. This image shows concrete experiencing shear failure. Concrete is strong in compression but weak in tension, and there is a tendency for concrete to crack on the plane subject to tension. When the tensile stresses are so high, it is necessary to provide reinforcement. The design of shear reinforcement is to provide steel to cross the diagonal tension cracks in the concrete and subsequently keep them from opening. Shear reinforcement increases the ultimate shear capacity of a bending member. Hussein shall now tell you what shear reinforcement is.
Steel reinforcement helps to counteract the relatively low tensile strength of concrete to create a composite material which is strong in tension. By doing this, it eliminates cracking in the concrete, in other terms, structural shear failure. Steel reinforcement should have the following properties: high relative strength, high toleration of tensile strain, good bond to concrete, thermal compatibility, and durability in the concrete environment.
Now over to Tahir in the lecture room.
In an attempt to economize in regions where the shear force is small and nominal links need to be used. This will require the above formula to be used backwards to determine the point at which the additional shear reinforcing can be reduced to nominal reinforcing. Given the same diameter links where the shear is higher than closer spacing is necessary to satisfy the ASV over SV ratio, while where the shear is less, larger spacing would be sufficient. As you can see on the board, this is a beam with large diameter and large spacing, and this bottom beam is small diameter with small spacing, but any possible failure in the plane will encounter the same ASV. And here is an example of a single link stirrup, wide 10. Thank you.
No, thank you, Tahir. But before you leave, please do tell us how to calculate shear reinforcement.
Shear reinforcement can be calculated with the formula shown, where ASV is the total area of links cut by failure, SV spacing between links, B breadth of the beam, V applied shear stress caused by the applied vertical shear force, VC shear resistance of that section with a 0.87 constant, and FYV where 410 MPAs are used for Y bars and 250 MPAs for R bars.
The future of shear reinforcement will move away from conventional methods, move away from the symmetry of steel reinforcement and the way its links are arranged to the use of materials such as fiber reinforced polymers and glass reinforced plastic. In other words, non-steel reinforcement would not need to be spaced accordingly and arranged in a certain way, but just be added to the concrete mixture to eliminate shear stress by the use of its interlocking properties.